Number two, we're supposed to, in writing, if we are given the graph of a function, describe how to write a rule for the function. I would say, essentially, it boils down to looking for a relationship between the input variable and the output variable. Of course, the first thing you always want to look for, let me just make a simple example. The first thing you always want to look for is, can I easily go from input to output with a one-step operation? Can I use addition, subtraction, multiplication, or division? So maybe I go 0, 3, 6, when I'd say, oh, well, 1 times 3 is 3, and 2 times 3 is 6, and 0 times 3 is 0. You know, this would be one-step multiplication. But sometimes it's not that easy. We might have a situation where, let me throw one more input value there. We might have a situation where we have, oh, let's see, 4, 6, 10. Oh, let me go back on that one. I'm not following my own pattern here. Let's go 8, and then we'll go 10 here. And we notice that, well, let's see, to go from 0 to 4, I'd add 4, but that doesn't work from 1 to 6. And to multiply 1 to 6, I times 6, but 2 times 6 is an 8. So when this is the type of situation, then we want to focus on our output values and say, well, what's going on each time? Every time the input value gets bigger by 1, each time this gets bigger by 2. Every time it's going up by 2. And I emphasize that word time because it tells us that every time we're going to times, it's going up by 2. Every time we have to times 2. Okay, well, what are we going to times 2? We're going to double the input. We're going to take the x value times 2. 0 times 2 is 0. And then we're going to add 4 to it. And there we have our equation, y equals x times 2, or y equals 2x plus 4. Now, that would be for this specific case. But in general, I think those are kind of the steps you want to take. Look for addition, subtraction, multiplication, or division to go from the input to the output. If that doesn't work, look for how much the output changes every time, and then write a rule from there.